And what that child was thinking. All right, so here's the problem once again, right? This is round 2 of me doing it. So the problem goes like this. At a local ski resort, you take a rope tow to the top of the bunny slope. Your displacement vector for this trip has a length of 198.33 meters and points at an angle, yes ma'am. You have physics this period? That's your schedule? So you're like brand new or?
No, I've been here.
I think I've seen you around.
Yeah.
Gonzalez, yes, I have seen you around. You're in the right period. I gotta see if you're an SB, but I'll give you a packet to work with in a moment, okay? All right. So just have a seat. Preferably not too far away. What was I saying? So, and points at an angle of 27.8 degrees above the horizontal, right? So horizontal is X or Y. Who knows? Which one is it? I got days of doing martial art. Which one is it? Which one is horizontal? Is that X or Y axis?
I think X.
You think X? What do you say?
Which way is horizontal?
He said X. What do you think?
Is it the long?
Or should I think the left?
If it's long, I think long.
You doing like hand signs. Okay.
Bro,
Is it what?
I don't know.
I'm like, what did you do?
Yeah, I think X.
It's X?
I say Y.
You say Y?
I'm wrong.
He's right. It's X axis.
I told you.
Horizontal, right? What do you do when you lay down? You horizontally lay down, right? Think about it. What do you do when you stand up? You vertically stand up, right? So y-axis. No, I'm not doing it to crack jokes with you. I just want you to know the difference, right? So you can see it for yourself. Now, they say during the ride to the top, you know, how many of y'all gone skiing? None of y'all? She gave me an evil look. I've gone skiing. It's kind of cool. Skiing?
Oh, yeah, I see it.
Oh, okay. So, you know, to get to the top of the mountain, you got 2 methods. You can climb the mountain, or you can take the little gurney all the way up, right? Yeah, the lift. That's what's called the lift, the problem. So, they should look real surprised. During the ride to the top, how far have you gone in A, the horizontal direction, that's our x-axis, right? And B, the vertical direction, that's our y, right? Now, I'm gonna take a pause for a second and go grab her packet so she can keep up with us. But y'all might want to turn to page 116. You go to the bathroom up there? You better hurry up, girl. You better knock this phone out. All right, so we get you a packet and stuff and all this and something to write with. You got one already? Okay. Fill out your name and then you go to the we do section. So you take notes, okay? All right, everybody, open up that book. It's going to help you so you understand what I'm writing. And the problem is pretty much you're going to have to write these notes. So at the bottom of page 116, there are some starter notes you're going to need to type up. Now, keep in mind, the little symbol that's by cosine and sine is called theta. It is not 0, all right? So with that said, you're going to need to copy down this box. So I'm telling you what you're going to copy under the we do section. Copy everything in the box, starting with the equations. I'm going to write it up here, but you should be typing it or writing it down in your we do section. It's the first part of your notes. So let's continue with this. This is your we do we're working on, right? And the notes you're going to need to start with is the vector conversions, and this is in terms of length, sometimes also said as magnitude, and angle, also known as degrees / theta. And this is for your components. And we talk about components, we talked about horizontal and vertical. Well, another way to say that is X and Y, right? So for our X-axis, horizontal, we have what? Well, there's two ways to write this, right? In the box, they give you things for radius, r. So Rx is equivalent to the radius given multiplied by cosine theta, right? Alternatively, another way to write this for the problem, because we have a distance going up the slope, you could say also dx is equal to the distance multiplied by, again, cosine theta. Now these are called theta. You didn't know what that means. That's how you look it up in your computer if you're typing it. Otherwise, you just write it like I wrote it. Those are Greek letters called theta in mathematics. Okay, so what about our vertical, right? This is our horizontal, our x-axis. What about our y-axis? So that'll be, respectively, ry is equal to r sine theta, right? And respectfully, you know, you could rewrite it as dy is equal to the distance given multiplied by sine theta. Two ways to write it. So just got to be paying attention whether you look for the radius, which is something circular, or you're looking for something that has a distance, right? So, or magnitude. So now we got that out the way, and we know what tools we're going to use for this problem. We're going to set up our ingredients. And this is basically what the problem gave us. If you want to follow along with what I'm doing, or visualize what I'm doing, turn to page 117 of this physics book, and you'll see the problem worked all the way out, which is pretty much all I'm doing. 117. That's the green book in front of you. So it shows you on this page how you would get up the mountain. This is what we were talking about earlier. We're going skiing. And you'd be carried from the bottom of the mountain up and dropped off so you can ski down, right? So we're calculating that slope, or resultant vector in this case, for our x and y components. Because if you look at it, it has an x component and a y component. It splits in the middle of it. So we calculate what each of those are like. So, what do we know about the problem? What does the problem give us, right? An unknown. What is the problem asking us? Right? Let's take it slowly. Anybody know what our first value for known is?
Distance?
It is distance. And what is that equal to?
198.33 meters.
Oh, I'm finna get on your case, yes. 198.33 meters. Joe Mel for 5 points. What else are we given in this problem? Huh? Angle, theta, yes. So we're gonna say theta is equal to what?
27.8.
0.8?
Yeah.
What?
I don't know.
Degrees. It's an 8. Ah, look at look at degrees. If you see theta, you know you have something in degrees or radians. We're going to be using just degrees for this part. When we do radians, we're doing more radius, more wheel revolutions and stuff, or RPMs. We're not doing it yet. So part A, there's two parts to this problem. What are we measuring? Yes, the x, I heard you. And that's measured in some number meters. And what about part B?
dy.
dy. That's our vertical. Okay? So now we got the formalities out of the way. Let's knock the problem out, right? So, part A. You're going to solve for dx, which is your horizontal component, right? X-axis. And we need to use that tool there. So we just say, hey, dx is equivalent to your distance given multiplied by cosine theta. And then the next step is, of course, plug and play. Everybody's favorite part of the problem. You plug in your numbers, which is easy to do because we already set up what goes in each value. So we know it's going to be 198.33 meters multiplied by cosine which is the trig function, cosine 27.8 degrees. Close that. And now I just calculate. So three ways you could do it. You could use Math Papa, which we used last week. You could use your calculator, right? And if you're using a calculator, you got to use something called a trig function. So I don't know how many of y'all had trigonometry, but to do so with these, they're all around the room. Y'all got UDO, so you got to know how to do it. So I hope you're trying to do it with me. You're going to type in 198.33 multiplied by, hit the trig button, and go to cosine. Type in 27.8, and you get 175.44 meters. Let's box that for a second. How about part B? Well, in part B, you need to solve for dy, which is our vertical component, or y component, y-axis. So use the equation appropriately. That's dy is equal to your distance multiplied by sine theta. Plug in your values, and we use the same distance. So that's 198.33 meters multiplied by sine, and the angle stays the same. So dy is equal to, let's take a look at what we got.
I got it.
You got it? What did you get?
92.49.
Yep. You got 10 points, pretty good. 90, he said 92.49. What is it measured in?
Meters.
Oh, okay. Thought I could catch him. I guess not. Okay. That was it for your introduction to vectors this week. All right. So take all your notes, and then you have 2 UDO problems, an exit slip, and then you got to turn everything in. All right. Ms. Gonzalez, once you get done with all the notes, I want you to try to work with these gentlemen to try to get your UDO completed so you can understand it. It's independent practice. It's not hard. It's basically doing what I did on your own. Okay, so let's set a clock, right? Because you gotta stay mindful of that. We get out of here effectively at 11:10. It's 10:39, so I want to say that's close to about 21 plus 10 more, 31 minutes of class, right? You set a clock for about 26 minutes, and I'm coming around and check and see how everybody's doing. Yes. Huh? Your footage? We got to find which laptop y'all footage is on, right? You talking about the footage you took on?
Friday.
Right, after we pull the data off? So, all right, I'll tell you what you do. After you're done with everything, we can pull your footage. You did with the UDO problems too? Yeah. All right, okay. Well, all right. So you can pull it now then. We got to find those laptops where we saved our data at before we did the transfer. So let me start. I started the clock? Okay. And I got to stop this. I forgot all about his running.